How does environmental assisted cracking lead to SCC? Imagine a tiny crack forming in a metal part that seems harmless at first. Over time, this crack can grow unexpectedly, causing serious failures. This is often due to a process called stress corrosion cracking. Now, how does the environment play a role in this? Let's find out. Environmental assisted cracking is when materials fail because of the combined effects of mechanical stress and a corrosive environment. Stress corrosion cracking is a specific type where cracks develop and spread because of this combo. It begins when tensile stresses, either leftover from manufacturing or from service, act on a vulnerable material. These stresses cause tiny damage or rupture in the protective surface film that normally shields the metal from corrosion. Once this film breaks, the metal underneath is exposed to the environment. If the environment contains chemicals like chlorides, sulfides, or alkalis, they make things worse. These chemicals speed up the process of metal dissolving or cause hydrogen to form. At the crack tip, a complex interaction happens between the mechanical stress and electrochemical reactions. The environment supplies aggressive chemicals that accelerate corrosion or hydrogen generation. This leads to localized metal dissolution at the crack tip. The metal weakens and the crack can grow longer. Hydrogen atoms produced during corrosion can enter the metal, making it more brittle and easier to crack. Factors like corrosion potential, electrolyte conductivity, and current density influence how fast the crack grows. Environmental conditions such as temperature, pH level, pressure, and chemical concentration also impact the process. Higher temperatures or more aggressive chemicals tend to speed up crack growth. Cracks can grow through the grains of the metal or along the boundaries between grains, depending on the alloy and environment. Cyclic stresses, like fluctuating loads, can make cracking worse by repeatedly breaking and reforming the protective film. This process causes cracks to extend gradually over time, sometimes taking months or even years to cause failure. Understanding how environmental assisted cracking leads to stress corrosion cracking helps engineers design better materials and structures. They can choose alloys less prone to cracking, apply protective coatings, control environmental exposure, or manage stresses through design changes. For example, reducing residual stresses during manufacturing or using heat treatments can make a big difference. In essence, environmental assisted cracking causes stress corrosion cracking by creating conditions where mechanical stress and corrosive environments work together at a microscopic level. This interaction leads to localized corrosion, hydrogen effects, and electrochemical reactions that weaken the material until it finally breaks. Recognizing these mechanisms helps prevent unexpected failures in industrial components exposed to harsh environments.